Hey everyone, today we're going to talk about the Pythagorean Theorem, and you have seen this before, if not once, at least once, possibly twice, if not more. So remember, Pythagorean Theorem only goes with right triangles, and there's a picture. Remember, your two shorter sides are your legs. Your longest side in your right triangle is your hypotenuse, and it is also directly opposite your right angle, if you're not sure which one is the longest side. So we're going to solve problems that involve right triangles, and we're going to use the Pythagorean theorem and its converse. And you're going to identify the right triangles and parts of the right triangle, use the Pythagorean theorem to decide if a right triangle exists, and use it to find missing sides. You'll know you'll have it when you score an 80% or higher on the assessment and or practice. So, jumping right in, the Pythagorean theorem for a right triangle with legs, A and B, and hypotenuse C, remember your Pythagorean theorem says A squared plus B squared equals C squared. Leg squared plus leg squared equals hypotenuse squared. So, let's take a look at an example. We have 3 centimeters on this leg. We have 2 centimeters on the other leg, my two shorter sides, and I'm looking for my hypotenuse. So we're just going to plug it into our Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared, and then we're going to solve it. So 3 squared, okay, and it doesn't matter which one you call A or B, okay, you could have started with 2, plus my other leg squared is equal to my hypotenuse squared. And you can call it C, because that's what we call it in the Pythagorean theorem, or you could call it X, Y, whatever makes you happy. Then you would do the math. Desmos is your friend. 3 squared plus 2 squared is 13. So 13 equals C squared. Now to undo, or to get C instead of C squared, to undo the squared, remember, you take the square root. Okay, and again, as always, what you do to one side of an equation in algebra, you do to the other. So I'm going to take the square root of 13. The square root of C squared. Okay, the reason I took the square root of C squared is I need C. And then if you type in the square root of 13, you get a decimal. So you can either write the decimal or you can leave it as the square root of 13. It's just going to depend on the problem, if you want to leave it as the square root, or if they want an actual decimal. If they wanted the decimal, okay, again, use your Desmos app, or you can go to desmos.com and square root 13. It's that big long decimal, 3.60555127546. Obviously, we would never write all that. But if they wanted the decimal, then we would say that the hypotenuse comes out to be 3.6. We're going to round to the nearest tenth. In the directions, I will usually tell you what to round. Now, make sure your answer makes sense. 3.6, is it bigger than your two legs? Yes. Okay, let's say you did the math and you came up with 1.5 for your hypotenuse. That should sound off an alarm for you, because your hypotenuse could never be 1.5. Okay, it has to be the longest side. So just a way to check yourself real quick. All right, example 2. Notice this time they are giving me a leg. Okay, I'm missing my other leg, and they're giving me the hypotenuse. I'm still going to use A squared plus B squared equals C squared. Leg squared plus leg squared equals hypotenuse squared. Okay, this time, I don't know one of my legs. If you wanted to start with 4 squared, you could. I'm just going to go A squared for the missing leg plus my other leg squared. Mostly I started with the variable because you guys usually like the variable first. Equals hypotenuse squared. My hypotenuse is 6. Now this adds a step of algebra. So watch how this comes apart. A squared plus 4 squared is 16. 6 squared is 36. Now, how would you solve this? Just like you would solve any other equation. A squared needs to be by itself. We're going to move the 16 to the other side by subtracting. So So I get a squared equals 20. Remember, I want just a, so I have to take the square root of a squared. So that means I have to take the square root of 20. Again, square root of 20, not going to be, 20 is not a perfect square, meaning when I try to take the square root, it's not going to give me a whole number. So Desmos, square root 20, 4.47, da-da-da-da-da, round it to the nearest tenth. I'm going to say it's 4.5. So my other leg comes out to be 4.5. And it's meters. Okay, they changed it. Make sure it makes sense in the context of your question. It is a leg, so it should always be smaller than your hypotenuse. 4.5 is obviously smaller, so at least I know I'm in the right ballpark. I don't know if it's exactly right without checking, but I can eyeball it and go, well, it's smaller than my hypotenuse, so at least I'm in the right area. But 4.5 is what we got, and so that would be my answer. That is how long this particular leg would be, 4.5 meters. The next thing they're going to ask you to do is they're going to give you sometimes a picture, sometimes not. Sometimes they'll just give you 3 sides. And they'll ask you, is this a right triangle? Now, a couple weeks ago, we decided whether or not if just a triangle would exist when they gave us 3 sides. Now they're asking me if it is a right triangle. So I have to approach it differently than what we did with the triangle inequality. If they ask me if it's a right triangle, I have to drop the numbers into my Pythagorean theorem and see if they actually work. So what does that look like? I'm going to take my 2 shorter sides and use them as my legs. So my 2 shorter sides are 3 and 3. So I'm going to say leg squared plus leg squared. What I'm going to be checking to see is when I square and add both my legs, does that give me the same value as my hypotenuse squared? Your hypotenuse is going to be your longest side, so that would be 4. So let's see if this actually works. 3 squared and 3 squared is 18. 4 squared is 16. Does 18 equal 16? Wah, wah, wah. No, right? Okay, so what this tells me, since 18 is not equal to 16, that these 3 sides, 3, 3, and 4, okay, do not form a right triangle. Okay, they may form just a triangle, just a basic, boring, not exciting triangle, but they will not form a right triangle. So leg squared plus leg squared, see if it actually gives you what it says you should get for hypotenuse squared. All right, another type of example that you are going to see is what they like to call real world. Okay, they like to throw these at you a lot. This is kind of how they'll show it to you on the SOL. They won't just give you a basic boring triangle and ask you to use Pythagorean theorem. They'll put it into a real world context. So this says, a storm is brewing and the ship, here's my little ship right here, here he is, must make it to shore as quickly as possible. Using the image above, find the distance between the ship and the lighthouse. So they were kind enough to draw it for you and put a little question mark. I noticed that I have a right triangle. As soon as you see right triangle, Pythagorean theorem should be one thing that pops into your head. There's another thing, but we haven't gotten there yet, so I'm not even going to talk about it. Talk about it next week. So right triangle, Pythagorean theorem, it's my a squared, b squared equals c squared. Make sure I know which ones are my legs. So again, shorter sides. So those would be my 2 shorter sides. They also make an L shape. Okay, they make an L shape and come together to make the right angle, if that helps you. So I'm going to say leg squared. And again, I could have started with the 130 if I wanted to, plus my other leg squared equals, I don't know, c squared. That actually represents how far it is between the ship and the lighthouse. So then again, please Desmos, okay, math mistakes should not be an issue at this point. So we're going to do 50 squared plus 130 squared, because I never want to try to calculate that in my brain. That's 19,400. Big number. Desmos is your friend. 19,400. Okay. To get C, I need to take the square root of C squared. What I do to one side, I do to the other of my equation. Again, do not expect you to know the square root of 19,400. Not in a million years. Square root of, oh, nope, don't want there. Okay, let's try it again. Square root of 19,400 is 139.28. Let's round to the nearest tenth. So that's going to be 139.3. Okay, so the distance between the ship and the lighthouse, because that's what they asked us to find, the distance between the ship and the lighthouse is 139.3. And since they told me, I'm going to put my units kilometers. Okay, so that's a decent distance. 139.3 kilometers. Okay. Just a real-world application of the Pythagorean theorem. Here's another one. Okay, and again, these are the way they will ask it to you on the SOL. They're not just going to give you a little triangle with some numbers on it. Using the dimensions in the image, find the height of the tree. Okay, so they want to know how tall it is from the top of my tree to the bottom of my tree. And I look, hey, look. And I can put a box there, okay, because in real-world examples with a tree or a wall, anything like that, they will let you assume that that is a 90-degree angle. So what am I looking for? Well, let's see what I got. This is a leg from here to here. That would be a leg. There's your L, there's your right angle, and that's my hypotenuse. So I am looking for a leg. Okay, and again, you can start with the 6.2, but I'm going to start with a variable because you guys like the variables first. So leg squared, and it doesn't have to be A or B. Okay, you could call it X, Y, Z if you like X, if you're super attached to X. A squared plus, what's my other leg? 6.2 squared equals my hypotenuse squared, 7.5 squared. Again, I don't know what 6.2 squared is in my head. Nope, don't know it. Desmos says 38.44. Okay, so I'm going to use it. And yes, I know you guys, I can split screen, but I don't like how little. If I had a bigger iPad screen, but it makes everything so small that it, okay, now I totally lost everything, that I don't really like to split screen it. 56.25. But you guys have better eyes, so knock yourselves out. If you don't know how to do it, let me know. I can show you how to do it. 56.25. Now, because I'm looking for a leg, there is an extra step of algebra. Okay, I'm not just going to take the square root yet. I got to move the 38.44 by subtracting. Okay, and ew, these are decimals, and y'all do not really like decimals too much. So I can just come back, 56.25, oh, nope, 56.25 minus 38.44. So that gives me 1781. Okay, last step. Now I can take the square root. And obviously 17.81 is not a perfect square because it's already a decimal. So you're not going to get just a nice pretty whole number. So now I'm just going to do square root 1781, 4.2. Let's round to the nearest tenth. So it would stay a 2. So the height of the tree turns out to be 4.2, and this time it's meters. Just make sure it makes sense in context with your picture. Is 4.2 smaller than your hypotenuse? Yes, so you know at least you're on the right track. All right, last little example right here, because this is how a lot of times they're going to ask you, or it's going to be presented to you. Which of the following triples, because they're groups of 3 numbers, form a right triangle? Choose all that apply. Okay, so remember, if they're asking you if it's a right triangle, you have to do a squared plus b squared and see if it really equals c squared. So come to the first one, 5, 12, 13. Leg squared plus leg squared. Does that equal, and that's why I put a question mark, because I'm not saying it really does. I don't know. I have to do the math. Okay, 5 squared plus 12 squared, is that the same thing as 13 squared? Okay, so you can just type 5 squared plus 12 squared into Desmos. It's going to tell you, well, I'll show you what it looks like. Do 5 squared, and you don't have to do it separate. Oh, look, it's 169. Okay, so you're going to write, because you have to show me work on these. You can't just say yes or no, or just start circling random things. Got to show me your work to back up why or why you are not circling it. So 5 squared plus 12 squared, 169. 13 squared, type it in your Desmos. You're going to see it's 169. Hey, is 169 equal to 169? Absolutely it is. So this would be a right triangle. So we'd circle it. So then we'd come here. Okay. Remember, leg squared plus leg squared equals hypotenuse squared. Make sure you're always doing the 2 shorter sides first. 20 squared plus 32 squared. Does that equal 41 squared? Okay. And again, when you start getting into these bigger numbers, I don't know what 20 squared plus 32 squared is. I know 20 squared is 400. I don't know what 32 squared is. 1424. And again, you got to show me your work. You can't just have something circled. Okay, if you just have something circled, I'm going to mark it and ask you to redo it. So then I do 41 squared. 1681. Okay. Are those two numbers the same? 1424, 1681? Absolutely not. So this would not make a right triangle. It might make a regular triangle, but it's not going to be a right triangle. All right, so going to give you 30 seconds. You're going to go on the clock to do this one, 16, 22, 39. So you're on the clock. You got 30 seconds. See what you can do. And I'm going to put it at 25 because I said you were on the clock like 5 seconds ago. Leg squared plus leg squared. See it if it equals your hypotenuse squared. Use your Desmos. Do not try to do these by hand or in your head. You got 10 seconds. 5, 4, 3, 2, 1. Nah. What you came up with? 16, 22, 39. Leg squared plus leg squared. Does it equal my hypotenuse squared? Put a question mark because you're not saying it does. You're not sure. Not going to do things in my head. I have my trusty Desmos. I love Desmos. Desmos is my friend. So 16 squared plus 22 squared, 740. I'm going to guess, and I could be wrong, that it doesn't, but let's see. Oh, not even close, right? 1521. Yeah, I knew 39 squared was a pretty good size number. Are these two numbers equal? No. Would this make a right triangle? No. Would it make a triangle? Maybe, but they didn't ask me that, so I don't care. And last but not least, 1160, 61. Okay. I'm going to check it. 11 squared plus 60 squared. And while I'm here, so I don't have to keep flipping back, 61 squared. Hey, 3721. Yeah. So 11 squared plus 60 squared is 3,721. 61 squared is 3,721. Are they equal? Absolutely. So your leg squared plus your leg squared actually does give you the same thing as your hypotenuse squared. So yay, right triangle. So, short, sweet, you've done it before. Pythagorean theorem, a squared plus b squared equals c squared. Leg squared plus leg squared equals hypotenuse squared. That's all there is to it. If you have any questions, let me know. If you're good, then head on over and work on the practice that goes with this. All right, let me know if you need any help. Bye.